Hi, this is Tim from Tiger Astronomy, and I'm going to talk a bit today about the ASCOM Settings Provider, which is something we put into ASCOM back in about platform 6.0, so it's been there for a little while, but the purpose of the settings provider is to kind of make it easier to manage settings in drivers. It lets you use all the Visual Studio designers and the stuff that's all built in to support settings, and it saves you quite a bit of code writing, and there is a few steps that you need to do to wire it into your project, and it's not in any of the template solutions by default. So as a result of that, a lot of people don't know it's there, and they end up doing a lot of unnecessary work. So I'm going to show you how easy it is to wire up and get working. So we're going to create a new ASCOM 6 project from the driver template that are in the developer tools. I'm going to call it ascom.demo.focuser, and it's obviously going to be a focuser project, not a telescope. So set up the focuser, and the name there is demo again. Create. Now, excuse me, the templates do actually generate completely working skeleton driver. It obviously doesn't do very much. So just to show that, I will first build the solution. Let's just close the README file. You should read the README file. There's a lot of useful information in there. But I'm just going to build the solution. Build succeeded. Okay, so I'm going to go into conform at this stage, just because it's a handy way to select a driver, and it's already remembered the ID here for me because I've actually run through this sample prior to making this recording, so conform has just remembered it. So I'm going to click the properties, and you can see we've got a default setup dialog box with not very much in it. It just has a text box where you can put the COM port and a checkbox where you can turn on the trace on and off. So I'm just going to OK that, and then what happens under the covers, if we just look in the ASCOM Profile Explorer, under focuser drivers, under ascom.demo.focuser, which is what we just created, then we can see our two settings, COM port and trace level, and there are their values. Okay, so this is the ASCOM Profile Store. That's where ASCOM drivers are supposed to save their settings. Now, so why do I not like the default situation? Well, let's take a look at what's involved in managing these settings. So if we look at driver.cs, which is the main driver file, in the constructor for this driver, which is around about here, okay, we have to have this read profile call, which reads settings from the profile. Now if I dig into that, this is what it looks like. It creates an ASCOM profile, it sets the device type to focuser, and then for each and every setting you've got, it has to you have to have this complicated line which provides a default value. It has to do a conversion from string to whatever type the field is. So here you notice this one's using 2 Boolean because when settings are persisted, everything is a string. No matter what type it is in memory, it ends up being a string. So you have to do all this type conversion. You have to have one of these lines for every setting. Now if you've only got 2 settings, it doesn't seem like much, but on a driver of any size, you can have tens or, you know, several tens of settings in a big driver, and managing all this code can get a bit tedious and a bit error prone. Not to mention that there's no error handling at all here. So that's just reading the profile, and also if we look at the setup dialog method here, line here checks that the user has actually clicked OK on the setup dialog box, and if that's the case, then this write profile method is called. And again, here you go, one line for every setting you've got. So the code's starting to balloon already, and we've only got two very, very simple settings. And then in the setup dialog itself, which we have over here, we can view code for that. You know, in the constructor for the setup dialog, we've got to retrieve all the current values and put them in the controls. And again, you know, there might very well be type conversions to be done here. And when the user clicks on OK, then we've got to take all the values out of the controls, put them back into the properties of the focuser, and also there's no error handling or validation being done on any of these controls. So if somebody, say, puts a stupid value into one of the controls, so let's say you needed a numeric input and you just had a text box for that, then that's not very type safe, whereas it would be better to have actual numeric control for that and be able to save that directly into settings as a number. Okie doke. So, rant over. Basically, you know, the reason is there's a lot of unnecessary code here, and the settings provider makes life a lot easier. So, I'm going to start by just stripping out a lot of the functionality that the template has put in. So I'm going to take out what happens here in the command OK. I'm going to take out what happens in the constructor here, because we won't need to do this. Okay, in the driver itself, in the constructor, we won't need to call read profile, and in setup dialog, we won't need to call write profile, but we will need to do something here. So just putting a note to myself, I can't do it yet, but I've just put a note to myself that I need to save the settings there. And also, if the user clicked cancel on the setup dialog box, i.e. the result wasn't OK, then we need to do something else here. So revert to old values. So we'll come back and have a look at that slightly later on. To do revert to old values. Okay, now, so how do we use the settings provider? Well, first of all, let me show you some of the reasons why this is desirable. We'll look at how Visual Studio supports application settings. So we're going to look at the setup dialog form itself. We're going to just click on the text box here for the COM port, and if we scroll right up to the top of the settings panel here, there is a thing called application settings, and there's a lot of magic hidden behind here that a lot of people just don't know about. So we're going to create a property binding, which means we're going to bind a property of this control. In this case it will be the text property, i.e. the value that appears in the control, and we are going to bind that to an application setting. So we need to click the browse button here. We're binding the text property. It's not bound to anything at the moment, so we need to create a new setting, and the setting is going to be called COM port name. I'm making this deliberately different from what was used before so we can see that the right thing has happened. And the default value I'm going to put in here as none, because no COM port's been selected yet. We could use COM1, and COM1 might be a more sensible default, but I just wanted to, again, to differentiate what we're doing from what happened before. So this is going to illustrate what's happening. The scope is set to user. It can be application or user, and I recommend that for anything that the user should be able to edit and that you set the scope to user, and anything you don't really want the user to edit you can leave set to application, although the use case for that is somewhat less obvious. So if in doubt, just leave everything set to user, which is the default value. Okay, so having done that, the first thing to notice is that our default value of none has appeared in the text box. And if you look at the text property of the text box control, the little red icon here, which has lit up, which if you hover over it says, value is bound to application setting. It won't come up now. Value is bound to application setting COM port name. Okay, and that's the default value there, which you can edit directly in that box. Okay, so we'll do the same again for the trace checkbox, and I believe, if I recall correctly, it was called trace level. The setting was called trace level before. So in our application settings, Visual Studio understands a bit about checkboxes, so it's exposed a couple of what it thinks are the most likely candidates that we might want to bind to. So checked is in fact the property I want, and in my colour scheme, apologies, it's really hard to see, but there is a link there that says new, which I'm clicking, and so we're going to call this trace enabled. Its default value is false, its scope is user. So, no change there. And once again, the little icons lit up next to checked, and value is bound to application setting trace enabled. Okay, so what have we achieved by this? We've basically made our controls have a hot link directly to the setting that they edit, which is really nice. Now, how do we need to, first of all, we need to think about saving the settings, loading them again, and accessing them from the right places at runtime. So let's just save everything. We're going to go into driver.cs, and in the setup dialog method, where we put these comments before to remind ourselves that there was something still to do. So to save the settings, I am going to just type the following line of code: properties.settings.default.save. Okay, now that one line of code saves all of your settings, no matter how many you've got. So instead of having to have a line of code for each setting, we've now just got one line of code that does everything. It takes care of all the type conversions, and it's just, in my view, a lot simpler. Now, if the user didn't click OK, then the only other option is they must have clicked cancel. In this case, what we want to do is properties.settings.default.reload, and that just reverts to all the old values. Okay, excellent. Now, in terms of loading, there is literally nothing to do, because settings just happen by magic. They don't need to be loaded, there's no type conversions to be done, and we just need to use them, basically. So how do we use a setting? Well, if we look for the fields that were being used before, these were the two settings: COM port and trace state. Now, let's just find COM port and see where it's used. Okay, it's actually just used in this. It's in the connected property, I think. Yes, connected, and it's just actually used in these two log statements. So we're not going to use the COM port field anymore. We're going to access our settings directly. Properties.settings.default.COM port name. And Visual Studio has generated that code for us, so we can just use these by name, and they're strongly typed. You can see it's a string. It will be more obvious in a minute. So properties.settings.default.COM port name. Okay, and then we can now we can delete these methods, but I'll do that in a minute. We can now where was that usage of comport? There it is. So that is now not used anywhere in the solution, so that can be deleted. I lied. Right, the resharper has just warned me I'm about to delete something that's used somewhere else. So, looking in dialog form, find comport, not found. Ho ho ho, what's going on? Comport. Find. Yeah, we get course read profile and write profile. So actually I need to delete these methods because they're just hanging on to those fields that I want to delete. So I've already deleted the calls to them, I think. So there we go, delete read profile, delete write profile. I'm using resharper to delete them, which is does an intelligent delete, but you can just literally select the lines of code and delete them. Now if we find comport, I'm just going to delete, and also now trace state, where is that used? It is used here in the constructor, and so we need to now again just access the setting directly. So properties, settings, default, trace enabled. Now you'll notice that the suggestion here is automatically the right one, and it's strongly typed and it's a Boolean. So brilliant. Now we could now delete that trace state field as it is not used anywhere in the solution. Okay, so let's build. Where are we? Notice now there's nowhere in the solution I'm loading the settings. I'm just using one of them is enough to get its value loaded. Okay, build succeeded. One succeeded. Now, we're not quite there yet. This will actually work or appear to work. So let's just, for the sake of argument, give that a go. And we're going to go into conform. And we're going to go select driver, properties, and notice that we've reverted to defaults because essentially our settings are no longer being taken to and from the ASCOM device profile. They're using Visual Studio's default mechanism, which is to save them in an XML file. So if I just put something in here like COM7 and turn on the trace, just so that we can see what's going on, and if I select that driver again and go into properties, you can see it has actually saved those values. So this is good. However, if we look in the ASCOM Profile Explorer, under Focuser Drivers, under ascom.demo.focuser, now mysteriously our settings are not there. So clearly something odd's going on here, and although everything seems to work, our settings are not yet in the right place. Now, this is where the ASCOM Settings Provider class comes in. What Settings Provider does is it creates the bridge from the world of Visual Studio's designers to the ASCOM profile store, because Visual Studio generates code by default that saves settings in an XML file next to the application that's running, and the trouble is that means that every application has a different set of settings, and that's not what we want with ASCOM. We want each driver to have one set of settings that work in every application. So this is why we need the Settings Provider class. Everything we've done up until now is just ordinary built into Visual Studio, and there's not really anything custom going on there. That's just the default behavior. So, how do we get the runtime to use our settings provider instead of the default one? Okay, well that's a good question. If we start on the driver project by double-clicking the properties node, and you'll see here is the settings designer. This is where our settings are in Visual Studio. And if we look, I'll just scroll this down slightly. If we look up at the top here, there's a menu item, View Code. Now when I click this, you'll notice a new file appear down here in the solution. So there we go, I'm clicking that, and there you go, settings.cs has appeared. And settings.cs is a internal sealed partial class called settings. Now, this partial, if you haven't come across that before, means that this class is defined in more than one file. Now, if you're curious where the other half is, if you look under properties, under settings.settings, and then there's this file, settings.designer.cs, and if we open that up, dire warnings in the comment here saying it's a code generated by Visual Studio. You mustn't edit it because your changes will be lost the next time you edit a setting. But here, internal sealed partial class settings. Okay, so that is the other half, the mysterious other half of this file. Now, the reason this is important is because we are allowed to edit this half of the class. This is our part of the code. Now, in these comments here, there are some useful event handlers that you might want to use later on for debugging. But just be aware they're there. I'm not going to uncomment them for now. All I'm going to do in this file is I'm going to add some attributes to it. Now, this is called decorating the class with attributes. So the reason, what's going on here is that I need to tell the runtime, anytime you see a setting from this class, don't use your default settings provider. I want you to use this settings provider that I'm going to give to you. So we need to apply a settings provider attribute. And that is something that's defined in .NET Framework. Now, have a care, this first one in the list, Settings Provider, ASCOM.SettingsProvider, is not the right one. It's not an attribute. So what we actually want is this one down here, Settings Provider from System.Configuration. So that's the one we're going to use. And then in the parameter, we need to specify the type or the class that is going to that has the settings provider in it. So we need its type, so we need to use the type of keyword, and then we specify here the ASCOM.SettingsProvider, like so. Okay, so that is enough to tell the runtime. Oh, hello, I've got a red squiggly. Cannot convert system.type to. Oh no, it's used the wrong one. Having told you to make sure you don't use the wrong one. Right, so settings provider is not an attribute. Okay, let's try that again. Settings provider from settings provider. Oops, no, not like that. Settings provider from system.configuration. There are two of them listed here in this link. Right, okay, that looks promising. Now, ReSharper has added the using system.configuration for me here. And probably also referenced it, but you may need to do that manually. Okay, so the parameter here, now we're getting the right sort of prompts here. We need a type, provider type. Okay, so we need the type of keyword, and we're going to specify ASCOM.SettingsProvider. That's looking better. Okay, So this tells Visual Studio to make sure it uses our settings provider for anything defined in this settings class instead of the default one. Now, there's another step to do, because the ASCOM Settings Provider needs to know which driver it's providing settings for, and there's no way for it to discover that at runtime. There just isn't anything to hook into, because all it can discover is which application is running, and so it needs to actually know which driver DLL it's providing settings for. So we come up with a mechanism for doing that called the device ID attribute, and the device ID attribute takes a string, which is the ASCOM device ID, which is ascom.demo.focuser in our case. I'm just going to leave that as an empty string for a moment. And then there's an optional parameter, which is the chooser name. So we need to, because it's an optional parameter, it needs to be specified like this. And again, I'm just going to leave that blank for a moment. And the reason is because these values are already defined elsewhere, and I'm a big fan of the dry principle, don't repeat yourself. I didn't want to put them in there as literals when I can get them from somewhere else. So, if we go now back to the driver.cs file, you'll notice that just here there is the driver ID and the driver description. Now, these are currently internal static strings. I'm going to replace that with public const string. They are constants, so they should really be constants instead of static. And I'm making them public so I can access them from the other file, from the other class, from the settings class. And now we should be able to go back into our settings class, and instead of these empty strings, I should be able to put a focuser.device ID, driver ID rather, and focuser.driver description. Okay, that's good. No repetition. Brilliant. Now that is enough information for the settings provider to work correctly. Now, so if we now build this solution, we've got a warning there, which I'll pretend I didn't see. If we now go into conform and go options, select driver, power driver. Now, once again, we've reverted to defaults because the addition of those attributes has in fact changed the location of the settings again from Visual Studio's default back to the ASCOM profile store. So now I'm going to put in COM2 in there, which again is a distinct value that I haven't used before, and I'm going to turn on the trace and OK that and OK that. And now if we look in the ASCOM Profile Explorer under Focuser Drivers, ascom.demo.focuser, lo and behold, here we have COM port name and trace enabled, and these are our settings. Now you can now merrily go on adding as many settings as you want in the settings designers in Visual Studio, bind them to your setup dialog controls, and everything else will be taken care of for you automatically. It's a big time saver, less opportunity for bugs, and I think it's just an all-around good thing. So that's the settings provider. That's me over and out. If you need help with your ASCOM drivers in other areas of your ASCOM drivers, then look me up on CodeMentor. I'm at codementor.io/Tim Long. Thank you and goodbye.